everyone, I am French Joy Lamos Tibahenteng, and in this video we're going to talk about the related rates. So first example, we have a water droplet falls onto a steel pan and creates concentric circular ripples that propagate away from the center, assuming that the area of a ripple is increasing at the rate of 2 centimeter per second. So find the rate at which the radius is increasing at the instant when the radius is 10 centimeters. So first, let's have an illustration. We have a concentric circular rifles. So next, let's identify those identities that involved with respect to time. So let R be the radius and A as the area. So after that, we're going to write down a numerical facts known about the variable about R and A. So the given rate of change is dA over dt is equals to 2 pi. Next is we asked to find the dr over dt. So when your r is equal to 10, so after that our r is or radius is equals to 10. So after that, the relationship between a and r is given by the formula for the area of a circle. So that is a is equals to pi r squared. So let's differentiate with respect to time. So dA over dt is equals to pi. The derivatives of r squared is 2r. So 2r dr over dt. This will be our equation. So after that, we're going to substitute the value of dA over dt and the value of r, which is 10. So we have 2 pi is equals to r times 2 times r, which is 10, or the radius, dr over dt. So r times 2 times 10, that would be 20 pi. Then let's divide both sides by 20 pi. So let's cancel. So we have dr over dt. So we have 2 pi over 20 pi, or 1 over 10. So our conclusion is the radius of a circular rifle is increasing at the rate of 1 over 10 centimeter per second. So the next example is a ladder 10 meters long is leaning against a wall. If the bottom of the ladder is being pushed horizontally towards the wall at 2 meters per second, how fast is the top of the ladder moving when the bottom is 6 meters from the wall? So First, we're going to provide an illustration. So, after that, we're going to identify this quantity and we're going to represent it using the variables. Okay, so our x is the distance between the bottom of the ladder and the wall. Then our y be the distance between the top of the ladder and the ground. So note that the length of the ladder is constant. So if the bottom of the ladder is being pushed horizontally towards the wall, that is dx over dt is equals to -2 because this rate is negative since the quantity x decreases with time. That's why it's negative. So that's negative. So we're asked to find dy over dt. dy over dt is so when x is equals to 6 meter. So we can apply the Pythagorean theorem rather, which is x squared plus y squared is equals to 100. Then let's differentiate both sides. So x squared, that would be 2x dx over dt plus y squared, that would be 2y dy over dt is equals to the derivative of 100, which is constant, is 0. So, and substitute the given, but first let's solve the value of y. So 6 squared plus y squared is equals to 100. So 6 squared, that would be 36 plus y squared 100. Then y squared is equals to 100 minus 36. So that would be y squared is equals to 64. So to remove the squared, let's put square root of 64. So the square root of cancel. The square root of 64 is 8. So our y is 8. Let's continue. So 2x 2 times 6 times -2 plus 2 times 8 dy over dt is equals to 0. So 2 times 6 times -2, that would be -24, plus 2 times 8, that's 16 dy over dt is equals to 0. Then 16 dy over dt is equals to 24. Then divide both sides by 16. So we have 24 over 16, or 3 over 6, or in decimal point, that would be 1.5. So our conclusion, thus the distance between the top of the ladder and the ground is increasing at the rate of 1.5 meter per second. Equivalently, we can also say that the top of the ladder is moving at the rate of 1.5 meter per second. That's all.